Hey students, how you doing today? Mostly Healthy Elliot is here to teach you your math lesson of the day. This is part one of a part two, this is part one of a two-part lesson. And in this one we're going to be writing exponential equations of the form y equals a times b to the x. Now, you might remember we've actually done this already, but when we did this previously, they always gave us the initial number a, and they also gave us the common ratio b, or they gave us something that we could common sense the common ratio. In these problems, they're not going to give us the initial value. They're going to give us just two random points on the graph. So if they gave us the two coordinates 3, 8, 7, 5,000, and we knew these 2 points fit an exponential model, because it says so in the instructions or something, how would we go about solving this? How would we go about writing the equation for this? Well, here we go. And we're going to use systems of equations. Excuse me. All right. Systems of equations. So first thing I'm going to do is I'm going to plug x and y into this equation, and I'm going to do that for both of these. So 3, 8, I get 8 equals a times b to the third power. And then for the other one, I get 5,000 equals a times b to the 7. Okay, now, side note for a minute. Do you remember when we had like 2x plus 3y equals 8 and 5x minus 3y equals 27, and we learned that because of this positive 3y and negative 3y, we could add the two equations together and get 7x equals 35, which gave you x equals 5. Same general idea. But because we were adding, because the x and the y were being added or subtracted together, that is what allowed you to add the two equations together. In this case, my two variables are being multiplied by each other. So instead of adding the equations like we did here when x and y were being added to each other, because these are being held together by a and b are being held together by multiplication, I can divide the two equations and get a variable to cancel out. Interesting. So I'm going to write this equation first. So 5,000 equals a times b to the 7, and 8 equals a times b to the 3. And if I go this equation divided by that equation, 5,000 divided by 8. Oh, maybe I should know that one off the top of my head, but I don't. 5,000 divided by 8 gives me 625. Equals a divided by a is 1, so the a's have canceled out. Bye-bye, a's. B to the 7 divided by b to the 3, well, as we've learned earlier in the chapter, that's equal to b to the 4. So I have b to the 4, and then you do your fourth root of both sides. Wait, that's not equal to 2. The fourth root of 625 is 5, because 5 to the 4 is 625. So I know that the fourth root of 625 is 5. So b is equal to 5. And just like as systems of equations, I could then rewrite my equation. So I have y equals, instead of a times b to the x, I now know that it's y equals a times 5 to the x. And now I just need to plug either one of these 2 points into the equation to figure out my a. So I'm going to pick the 3, 8 because the numbers are smaller. If you pick 7, 5,000, it will work, but it'll be higher, bigger numbers, more work. So use the smaller numbers. 8 equals a times 5 to the 3. 5 to the 3, everybody knows, is 125. So I have 8 equals 125a. Divide both sides by 125, and you get a equals 8 over 125. So our final equation is y equals a times b to the x. 8 over 125 times 5 to the x. That was when I was given 2 coordinates. Okay. One question I would anticipate getting is, did we have to go this equation divided by this equation? And the answer is no, kinda. You want to go the bigger numbers divided by the smaller numbers. Or another way of thinking about it is you want to go the bigger exponent divided by the smaller exponent so that this exponent stays positive. Let's see if you did it the other way. It would be 8 equals AB cubed and 5,000 equals A times B to the 7. And if you divide this, you get 1 over 625 equals B to the negative 4. That's kind of confusing. What would be the best way to approach it then? Well, I guess you just need to know. I guess I could think of this as 1 over b to the 4 equals 1 over 625. And because the numerators are equivalent, the denominators must be equivalent. So I get 625 equals b to the 4. Then I do my 4th root and I get an answer of 5. But hopefully you saw, like, you don't want to deal with these negative exponents. It's more work. So just go the bigger exponent divided by the smaller exponent. That'll keep the exponent positive. Okay, I have just one more example in this lesson. Suppose the two coordinates are 2, 5 and 8, 20,480. Okay, hey, you saw example 1. If example 1 made sense, pause example 2, see if you can do example 2 on your own, and then hopefully we'll end up at the answer together with the same answer, and everybody's happy. Okay. I'm pausing while you guys are working on this. I'm going to take a quick sip, then I'm going to start this. All right. Bigger one first. So 20,480 equals A times B to the 8. Then the smaller one. So 5 equals A times B to the 2. Divide. 20,480 divided by 5. 4,096. A divided by A, gone. B to the 8 divided by B to the 2, B to the 6th. You raise both sides to the 1/6 power, or you could think of it as I do the 6th root of both sides. This is not one that needs to be memorized on your list, so I'm going to go ahead and just use my calculator here. And when I do the 6th root of 4,096, I got an answer of 4. So B equals 4. So I now know that of A times B to the x, my B is equal to 4. So I have y equals A times 4 to the x. And now I'm going to plug my xy coordinate into the equation. So my y is going to become a 5. My x is going to become a 2, so A times 4 squared. That becomes a 16, so 16a. And when you divide both sides by 16, A, my friends, is equal to 5 over 16. So your final equation is y equals A, 5 over 16, times B, 4 to the x. I guess these problems are probably more likely to be answered in a calculator section because of the large roots that we have. But always make sure that you have the root list that I've been mentioning in class fresh. Okay, everybody, that's it. I've scored a lesson under 10 minutes. This is just part 1. So part 2 is going to be the same thing, but it's going to be story problems. So the coordinates won't necessarily work out or be pretty. So you could watch that video right now, or you could watch it on over the weekend and work on Monday. It's your choice. Do what you want, everybody. Have a great day. I'll talk to you soon. Bye-bye.